Number 3, the accompanying table shows the number of new cases reported by the Nassau and Suffolk Country Police Crime Stoppers program for the years 2000 through 2002. We have a table of values here, and normally we would do time equals 0. So years since year 2000, we would put in a 0, 1, or 2. But in this problem, it tells you if x equals 1 represents the year 2000 and y represents the number of new cases, find the equation of best fit using a power regression. Okay, this is new, a power regression. It's meant to launch us into lesson 2.8 where we can see that this is not linear. And I will prove to you why it's not linear using all of lesson 2.7 and 2.6. And then it tells us to figure out what happens in year 2007. Okay, so I've noticed some weak points of the apps I've shown you guys on the iPad, and so what I'm going to use 2 tools. One is Desmos, and the other tool will be actually the old school graphing calculator. So from here, I'm going to press the plus sign. Make sure I get that, and I'm going to click on table here. I'm going to go ahead and simply put in the numbers: 1 for 57, 2 369, and 2 353. Okay, to get a linear regression equation, you're going to press the plus sign, and then you're going to press expression, because it's a new one. I'm going to type y1. You don't have to do anything. It makes it sub, makes sure it goes down list. And then you need, to the left of your one number, I don't know what this symbol is called. Whoops. Looks like a squiggly. Nope, that's not what I want. Squiggly. Okay, mx1, just type the letter 1, plus, so shift, plus b, okay? And what it's done for us is that it has given us the correlation, which is the strength, how close it is, coefficient of determination, and it's given us the slope. Whoops. See, if I made a mistake, you can even type in 3 and it changes automatically for you. Let's see. Okay. Okay, so from here, on the graph side, you can't see it. I have 1, 2, 3, and then around 350. So click on the wrench up here on the top right, and this is a difficult one. So the x-axis, I'm going to go -1 to 4. I'm counting by ones, and then over here on the y-axis, I'm going to go from 0 to 500, and I count by 50s. Okay, so here you are. This is what the graph looks like. Do one more out, okay? And those are my points, and then the black line is the line of best fit that has this as your slope and your y-intercept. Okay? All right. Now, the next lesson was in lesson 2.7 was to check the regression. Not the regression, the residual plots. So if you actually press plot, and you see in blue, this is the residuals, and it looks like it has a pattern. And so residual plots, when there's a pattern, this means that the regression is not, linear regression is not a good model. You have to use something else. And so eventually we're going to use something else. We're going to be using power regressions. And I'm going to experiment because I've never done this with Desmos. So let's try it. Y1 b to the x power. Did it give it to me? No. I don't know how to go up. Let's try them. X. 1. Okay. So there in red is my I'm using a different function. This is called a power, and it tells us that, well, what information do we have here? My coefficient determination is 0.88, pretty high. It's higher than the linear. And you can even check the residual plots for that one. Let's plot it. And I think it is the green ones. So kind of no pattern, doesn't look like a linear, but that's how I would calculate this problem. And then I can just this one wasn't a good one. I think the graphing calculator would be better. But let me go over the second problem with Desmos. I'm going to clear all this out. I'll just create a new one. I don't want to save this one. New blank graph. Okay, there we go. Okay. Let's go ahead now and try that question number 5. Okay, the numbers on that one says since 1980. Now, in this problem, it doesn't tell us to use the first year to be 1, so I'm just going to type in 1980, press tab, and then get 14. 1985 and 20. 1990 and 22. 1995 and 28. 2000 and 37. I'm going to go to plus sign, expression, and y1, the squiggly next to the 1, mx1 plus b. Okay, so there is my slope versus parameters and my y-intercept. So that's my equation that would get. Pretty strong on both, and then if you plot this, let's see, I might have to zoom out. There it is. Zoom in, you can change the x values. Okay, so green is just plotting it, pretty strong, positive, and then this is the residuals, which shows kind of no pattern, so a linear would be a good model for this problem. Okay, let me show you guys now how to use a graphing calculator. All right, so let's use our graphing calculator here. I'm going to press Stat and then Calc, and then I'm going to go ahead and input all of those numbers, which I already have, into the calculator. You'll notice in list 1, I did clear it out. Which question am I doing here? I'm doing the year 2000 equals x equals 1. That's why I have a 1 here. 2000, 2001, 2002. And then list 2, I have 457, 369, and 353. So now I'm going to go to Edit, Stat, Edit, Calc, number 4, linreg, and in there you can also do something different where you do to store the equation. You're going to press vars underneath the down arrow, y vars, and then function, and hit y1. And what that will do is it will store it into the y1. Press calculate, and then there our a value is the slope, and the b value, 497, is our y-intercept. And now you've created a linear regression. But this problem kind of tells us that it is a power regression. How do I know that? Well, you're going to have to look at the residual plots. So if you click y equals in the top left there, you see that the equation is now in there, and you could now evaluate it. Okay, so how do you get this residual plot? So you're going to press y equals, second y equals, so get the stat plot, and you're going to press enter on the first one, and then on your to X list, Y list, under the Y list, let's change that to, let's show you how to get a residual. So you can press list 2, that's second number 2, and then press zoom, and then zoom stat number 9. Okay, so there's my linear regression equation, and then there are the points, 3 points. Right, so we think it's a linear regression. My R value is not on. I forgot to turn the diagnostics on, but we can check the R value and the correlation determination. But if you go back to stat plot, so y second y equals, go down to y list, and here you're going to press second stat, and then go down to number 7, and you get resid, which is residuals. So now it's going to graph the residuals for me. I'm going to go ahead and press zoom number 9, and there we have a graph of the residuals. Remember, no pattern is good, and it's good for a linear regression, but this one shows a pattern, which means that it looks quadratic or even exponential / power function. So let me show you guys how to get a power regression. So go under calc, and then go ahead and go down, and there you have power regression. Okay, I have this one, this 2, that's what I want. Now I want to store that regression equation in a different one. So you're going to go to vars, which is near the down key, and then y vars, and then y2. Calculate, and there it is. 451 is your, not slope, but it's your point that goes in front. And then the exponential will be to that negative number. Now, if you go to y equals, we stored it there, and there you see the equation under y2. And now we can put in that number, because we're supposed to estimate the number of cases for the year 2007 round to the nearest whole number. So 2007, I believe, is x equals 8. So basically we're putting x equals 8. So I'm going to do that by going under table set. So second window, and you can have it under auto or ask auto. So change the independent to ask. And then go over to second graph on the top right, second graph, which gives us the table. And you put in x equals 8 there, and then that's the answer that we got, 272. Okay, in the next problem here, I've already inputted the value, so we're going to question number 5 now. And this problem doesn't tell me to use x equals 1 for the first year. So I'm going to go ahead and I just put in 1980. I put in all those numbers, and I'm going to do a lin reg. We're going to go ahead and store that regression equation again. So press vars, which is near the down key, and then y1. And I'm going to go and press calculate, and there I have the a value, which is my slope, and the b value, which is my y-intercept. And remember that negative 2,125, so you can just put in a year. Remember, you can get resid by just pressing second stat, and you basically get a residual plot. So I'm going to go to second y equals, make sure it says L1, and then to get resid, again, you're going to go to second stat and then resid. Residuals, and then zoom number 9. zoom number 9. So here's a residual plot. So you'll notice that there is no pattern. No pattern means it's a good linear regression model. If there was a pattern, kind of looks pattern, then we would use something else, okay? So here's a graph of the linear. I'm going to go back to second, y equals the stat plot there, and put in list 2, so that'll be second, number 2, and then press zoom number 9, zoom stat. And there's my least-squares regression line. And then those are my points. Points above, those are the 3 points in the residual plots that are above, and the 2 points below are the 2 points on the bottom of the residual plots. Okay? See you guys.